Stay safe and healthy at home. I am starting the next chapter, that is Gauss's theorem. So before knowing that, you must know about the area vector. That already I have given you the concept in 10th standard, 11th standard itself. So everybody knows that if you consider a certain area, then we consider this area as a vector quantity. Alright, just why? Just you consider, if you consider my hand, my palm, then you see the palm has two surfaces, the upper surface and lower surface. Alright, so if I want to refer to the upper surface, then how I can refer it? Then this is the way. Consider a vector perpendicular to the surface itself. Alright, so if you just consider a vector perpendicular to the surface, alright, and whose magnitude is equal to the area of the surface, then that is known as the area vector. Alright, so if you consider that n is the unit vector along this area vector, then what is the, how you can write down the area vector? The magnitude of the surface area multiplied by the unit vector along the direction of the area vector. Alright, so what is the very simple concept of area vector? Area vector is a vector which is perpendicular to the surface and whose magnitude is equal to the magnitude of the area of the surface. Alright, so this is the concept of the area vector. Next is the concept of solid angle. Already you have got in lower classes also. Means if you consider this way an ice cream cone, just you consider that this surface is circular, then if you join every point of the circumference of this circle to the vertex, then you see at the vertex angle is created. I hope you can see that one is known as the solid angle. So if I draw it, then solid angle, how you can write that? Suppose there is a circular surface and you have joined each and every point of the circumference to the vertex, then here the angle formed, this is known as solid angle. Alright, so if I consider this solid angle is d omega, alright, and if you consider this is the surface ds and r is the perpendicular distance between the vertex and the center of the surface, then you can write it down. You can write it down as d omega is equal to ds by r square. Alright. Now I hope you just compare it with the plane angle. Plane angle, how you write? That if this is s, this is r, this is theta, then you know that s is equal to r theta, theta is equal to s by r. Alright. So it is dimensionless. Angle is dimensionless. So when you are considering the plane angle, then you see it is coming s by r. S is the arc, length of the arc. So when it is considering the solid angle, it is three-dimensional representation. So you see what is the dimension of ds. ds is not the, unlike here, this is the length of the chord and ds is the area of this circle. Alright, what is ds? ds is the area of this circle. See here, so you see what is the dimension of ds. Dimension of ds is L square and d omega is dimensionless. So you see it should be ds by r square. So this is the basic relation between the solid angle and this is the, means r is the radius vector. Clear? And r, how you are getting? It is the line joining the vertex and the center of the circular area. So this is the basic concept of the solid angle. Now consider this case of solid angle. You see here when we have taken the base and r, they are perpendicular to each other. Just you look at it. What is the direction of area vector here? The direction of area vector dA is along this direction, isn't it? I have represented it by S. So everywhere I must write it as S only. So you see, what are you getting? What is the direction of ds? Direction of ds is in this direction. Alright. So look at ds and r. ds and r, they are in the same direction for this particular case. This is the simplest one. Alright. Now, if you consider that your base is like this. Alright. In that case, you see what is happening to the direction of ds and r. You see here, this is the base. I hope you are understanding, girls. Alright. This is the base. So, what is the direction of the vector r? The vector r, it is having this direction. Alright. But, if I consider the area vector ds here, what is the direction of area vector? Perpendicular drawn to this surface. So, you see it is acting in this direction. ds and r, they are not acting in the same direction like this case. Okay, rather ds and r, they are making an angle theta. Okay, so you see here, understand it. If this is the area, original area, and this angle is theta, then if I take the component of this area perpendicular to r, then this will be the component. You see here, this area if I take, then this area when I am taking, it is perpendicular to r. And what will be this area then? It will be ds cos theta. Because if this angle is theta, then you see here, just try to understand it. I am just trying to show you by my this one hand. This is the original surface and I have taken the surface like this. Alright. And what is the angle between these two? That is theta. So what is the component of this surface along this? It will be ds cos theta. You know, no. If there is a vector here, a, and if you want to take what it is component along this direction, what it is? A cos theta. So like that, if this is ds, what will be its component along this? Angle between those two surfaces theta. So it will be ds cos theta. So now you see ds cos theta r, they are perpendicular to each other, just like this. So you can write what will be the solid angle d omega. D omega will be ds, I am sorry, I have used s, ds cos theta by r square. So this is the general relation for solid angle. Is that clear? So you have to remember the relation, the ultimate relation for the solid angle to understand the next topics in this chapter. Means, what is the concept you have to remember? That when the area vector and means when the surface, suppose this is the surface and this is r, they are like this, then what will be the solid angle? Solid angle will be ds by r square. But when the surface is like this, alright, whereas this is the position of r and this is ds, then what will be the expression for solid angle? It will be ds cos theta by r square. Alright. Now, ds cos theta, you can write it as ds cos theta, one can write it as it is nothing but the surface area dot r, ds dot r. Isn't it? A dot b is ab cos theta. So you see ds dot r, you can write it as magnitude of ds into magnitude of r is 1 cosine of the angle between them. So this is the vector representation of d omega and this is the magnitude of d omega. Clear to everybody? So these are the two relations you have to remember, learn and remember to solve the numericals. Next concept is concept of electric flux. Alright, the most important and basic concept for this chapter. So try to get a very clear concept of this electric flux. What does electric flux represent? It is the number of lines of force crossing any area held in an electric field perpendicularly. Just you consider, I am just giving the example. Suppose there are electric lines of forces are like this and you have taken certain area. Alright, so the number of lines of forces passing through the area perpendicularly. Number of lines of forces passing through the area perpendicularly is the measure of the electric flux. So according to this diagram, you see how many lines of forces passing through this area perpendicularly. 1, 2, 3, isn't it? So electric flux you may consider as the 3. Is that clear? So what is the basic concept of electric flux? Number of lines of forces crossing any area held in an electric field perpendicularly is considered as the electric flux. Alright, now let us try to find out what is the relation. Now, as for just considering, we are not considering that electric field are like that. Let us consider the electric fields are passing like this. Alright, but you are holding the area like this. Now, look at this one. This is the electric field line. So, you can consider electric field intensity is E along this direction. Alright, and you are holding the surface like this. So, in this particular case, is E perpendicular to the surface? No, E is not perpendicular to the surface. Alright, so how you can get it? Now, let us consider what is the direction of the area vector in this particular case. What is the direction of the area vector? In this case, it is ds. Alright, now you see, if you consider the component of E along this direction of ds, then the line will become perpendicular to the particular area you have considered. So you see, if I consider this is theta, then if I take the component of E cos theta, then E cos theta is becoming perpendicular to the surface. Alright, and according to the concept of electric field intensity gives us what? Number of lines of forces crossing unit area perpendicularly. Understood? Here, so what you are getting, E cos theta giving you the measure how many lines of force crossing unit area perpendicularly. But in this case, we have taken the area ds. Okay, so what is the number of lines of force? What are the number of lines of forces crossing the entire area ds perpendicularly? It will be E cos theta into ds. So you can write like this, d phi e. Here remember, just understand it, phi e represent, phi e is the symbol for electric flux. Why I have written d phi e? Because I have taken a very small area ds. Okay, so what is the number of lines of force crossing the area ds perpendicularly? It will be E cos theta into ds. So I am repeating the concept once again, and you know, actually I am not getting the confident because I cannot see you and I cannot see your facial expression whether you are understanding or not. So that's why I am repeating it once again. Alright, please try to get it. That this is the direction of E. Clear? So this is not perpendicular to the surface considered, but ds perpendicular to the surface is along this direction of area vector. If I consider this angle is theta, then E cos theta, magnitude of E along this ds, it is perpendicular to the surface, and electric field intensity give you number of lines of forces crossing in unit area perpendicularly. So E cos theta is the number of lines of forces crossing unit area perpendicularly. So what will be, now apply the unitary method, what will be the number of lines of forces crossing area ds perpendicularly? It will be E cos theta into ds. So this is the electric flux associated with the surface ds. Alright, so you see, this is the relation you should remember, that d phi e, electric flux associated with any surface, it is given by E cos theta ds. So you see, you can write it as E ds cos theta. Alright, so in terms of vector, you can write it as E dot ds. Clear to everyone? So this is the relation you are supposed to remember. This is the relation you are supposed to remember to solve the numericals. So d phi E, electric flux associated with the surface, it is the dot product of electric field vector and the area vector. Alright, it is dot product of what? Electric field intensity and area vector. ds is what? Area vector. So you see, if I want to find out the entire electric field through any surface, then according to concept of calculus, what you can write? It is nothing but E dot ds, and the integration is over the surface. Clear to everyone? So this is the concept of electric flux. So electric flux is surface integral of electric field vector. Next one is, what is the SI unit of electric field? Now you see, what is electric field? E into A. So E is what? F by Q. F is Newton. Q is Coulomb. So Newton per Coulomb, and area is meter square. So what is the SI unit of phi E? Newton meter square Coulomb to the power minus 1. Alright. Again you know electric field, you can write it as that when I will teach you the potential chapter, you will get it. That V is equal to E into D. Alright. So E is V by D. Means unit of E is volt per meter and unit of area is meter square. So you can write it voltmeter. So these are the two SI unit, means same only, two different way to write the SI unit of phi E. You must learn and remember it. Then coming, what is the dimension of phi E? Dimension of phi E, how you can get? If phi E is E into A, cos theta has no dimension. So what is the dimension of E? Dimension of F by dimension of Q. What is dimension of F? ml t to the power minus 2. What is dimension of Q? A into T. So you see, what is dimension of E? ml t to the power minus 2 by A into T. Then what is the dimension of area? It is L square. So what you are getting? M L cube t to the power minus 3 a to the power minus 1. Is that clear? Here I should write dimension of S because I have represented area vector by S, not A, in the previous one. So you see, what is the dimension of phi E? M L cube a to the power minus 1 t to the power minus 3. So I hope everybody has understood the concept of area vector, concept of solid angle and concept of electric flux. I am summarizing. Area vector is the vector perpendicular to the surface, and what is a solid angle? D omega is given by ds cos theta by r square, and what is electric flux? Electric flux is given by d phi E is equal to how much? What I said? How you can get the electric flux through any one, it will be E dot ds. Alright, surface dot product of electric field vector and area vector. Clear? Now coming to the Gauss's theorem. So until and unless the concept of solid angle, electric flux, area vector is not clear, it will be difficult to understand Gauss's theorem. So first try to build up a very solid concept on that three, and then you come to the Gauss's theorem. So what does Gauss's theorem state? Gauss's theorem states that the electric flux passing through a closed surface, I repeat, through any closed surface, is equal to 1 upon epsilon naught time the charge enclosed by the surface. Alright. So just you consider this one. Consider this closed surface. Alright. So this closed surface, it is enclosing a charge Q. Clear? So according to Gauss's theorem, what will be the total electric flux passing through the surface? It will be equal to Q divided by epsilon naught. Alright. Electric flux crossing through a closed surface is equal to 1 upon epsilon naught time the charge enclosed by the surface. So what is the total electric flux? Mathematical expression, integration E dot ds. So here you see on the integration I have drawn a circle. What does it mean? Because in Gauss's theorem I said that electric flux through a closed surface. So this symbol indicates the closed surface. Alright. Integration of E dot ds is done over a closed surface and it is equal to how much? According to Gauss's theorem, 1 upon epsilon naught time the charge enclosed by the surface. So you see, understand it, if the surface is not enclosing any charge, then what will happen? What will be the electric flux? According to Gauss's theorem, it will be 0. Alright, or if it happens just like this, suppose there is a surface and within the surface the charges are plus q minus q, then what is the total charge? Total charge enclosed by the surface is 0. So what will be the electric flux through this surface? Electric flux through this surface according to Gauss's theorem will be 0. And I hope you have not forgotten what does epsilon 0, epsilon naught represent. Epsilon naught is the electric permittivity of the free space. Alright. Now we have to prove the Gauss's theorem. So the statement of Gauss's theorem and mathematical expression of the Gauss's theorem, everybody should learn for your board exam. I repeat, the statement of the Gauss's theorem, very simple, and the mathematical expression you must learn for the board exam. So in your own way, put a mark here that you should learn and remember it till your board exam. Now, what is the proof of the Gauss's theorem? So, we have to prove that the electric flux passing through this is equal to q upon epsilon naught. Clear? Now, how I can do this? For that, I have chosen a small area on the closed surface. Alright, just look at this. We have chosen a small surface area ds on this surface. On the means original closed surface. Now here you see, if I consider this, then what is the direction of the electric field intensity at this point? Electric field intensity according to Coulomb's law, it will be along the line joining the charge and the point. So you see, if you join the charge and the point, this is the direction. So this is the direction of the electric field intensity. Now come to the direction of the area vector. Area vector is perpendicular to the surface chosen. So you see, this is the small surface chosen. So perpendicular to it is ds along this direction. So E and ds, they are making an angle theta. Clear? So what is the small electric flux passing through the small surface chosen? According to concept of electric flux, we know electric flux d phi E is given by E dot ds. I hope you can remember. Just few minutes back I discussed. So E dot ds is what? E ds cos theta. Is that clear? So d phi E, the electric flux associated with this small one is E ds cos theta. Clear? Now we apply Coulomb's law. And we can write down what is the expression for the electric field intensity. What is the expression for the electric field intensity? 1 by 4 pi epsilon naught, then the source charge. What is the source charge? Q divided by square of the distance of that point from the source. So you see, what is that? R. So you can write it as Q by R square, then ds cos theta. Alright. Now you see, I can rearrange the term this way. I can write it as Q by 4 pi epsilon naught. Then I have written ds cos theta by R square together. Alright. Why I have written ds cos theta by R square together? Just you see, ds cos theta by R square is nothing but the solid angle d omega here. So you can write it as Q by 4 pi epsilon naught d omega. Is that clear? So, if I want to find out then what is the total electric flux? What is the total electric flux through the entire surface? Means phi E. What will be phi E? It will be integration d phi E. Is that clear? So integration d phi E means what? If I substitute the expression we have got for d phi E, you can write it as you can write it as Q by 4 pi epsilon naught, Q by 4 pi epsilon naught d omega. Hence, now you see Q you can take outside the integration, 4 pi epsilon naught you can take outside the integration. So it is integration d omega. Alright, integration d omega means the entire solid angle, and integration d omega is nothing but 4 pi. I repeat, integration d omega, it is nothing but 4 pi. So you see what you are getting, 4 pi get cancelled. So Q by epsilon naught. So what is phi E? The electric flux associated with the entire surface, Q by epsilon naught. Clear to everybody? So that is the proof of the Gauss's theorem.